Hi Senior Stage at Scale. We're going to be looking at solving simultaneous equations using the substitution method. What are simultaneous equations? Well, simultaneous equations are sets of equations that operate together to solve a problem. And the way that you have to find the value of the variables is a little bit more tricky than the single equations you've been working with. I'm going to start off with a really simple real-world problem that you can probably solve in your head. But that's okay, because it's nice to find the maths meets up with what you know in your head. Over here, there are two sentences. A tempo costs R2 more than a lunch bar, and a lunch bar and a tempo together cost 16 Rand. I'm going to use this information to set up equations and find out how much a tempo costs and how much a lunch bar costs. So let's take the first sentence. A tempo costs R2 more than a lunch bar. To write that sentence as a mathematical equation, I'm going to say a tempo is a lunch bar plus 2. I'll worry about the Rand later. So there's an equation that expresses that first sentence. I'm going to call that equation 1. Then a lunch bar and a tempo together cost 16 Rand. As an equation, a lunch bar and a tempo together cost 16 Rand. So now I have two equations that are describing the situation and I need to try and solve them. When we use the substitution method, what we are looking for is we are looking for parts that are equal to each other. So as an aside, if I've got in equation 1, t is equal to L plus 2, then it doesn't matter if I've got t or L plus 2 in the next equation. Those are worth the same amount. So what I notice here is there's t there, and what I can do is replace that with L plus 2. And that will create a bit of magic and turn this into a problem that you can solve. Usually when we're doing these, because they can become confusing, we write down the details of what we're doing. So the first step of mine is to substitute equation 1 into equation 2. So I'm just using an abbreviation for substitute, and 1 into 2. So I write down equation 2, L plus T is equal to 16. And then instead of T over here, in the next step, I am going to write down L plus 2. And I can do that because T and L plus 2 are equal. The next step is L plus, now I'm going to do the substitution, L plus 2. Now you should be able to see that that L plus 2 takes the place of the T in the line above, is equal to 16. Now I have 2L plus 2 is equal to 16. I need to isolate this L, or this 2L, so I'm going to subtract 2 from both sides. If I subtract 2 from the left-hand side, I'm left with 2L. And if I subtract 2 from the right-hand side, 16 subtract 2 is 14. Now I can divide both sides by 2. And on the left-hand side, 2 divided by 2 is 1L, is equal to 7. I have found out what a lunch bar costs. A lunch bar costs 7 Rand. Then equation 1 tells me that a tempo is 2 Rand more than a lunch bar. So already I know that a tempo is 9 Rand, but I need to set this out mathematically. So what I'm going to do is I'm going to say now I am substituting. So I'm going to substitute 4L in equation 1. And so I'll have equation 1 is t is equal to L plus 2. And so now it's t is equal to, instead of writing L, I am going to put 7. So it's 7 plus 2. And so I get t is equal to 9, which is what I'd already worked out in my head. The nice thing about these simultaneous equations is that you can check whether your answer is right by just going to back to the second equation. So I'm going to check in equation 2. Equation 2 says L plus T is equal to 16. According to my working out, L is 7 and T is 9, and that is equal to 16. So I have 16 equal to 16. I know I've got the right answer. So let's just go through this again. You don't always have to set up your own equations. Most often you're just given the equations. You've got equation 1 and equation 2. What you need to do is you need to look at the simple equation, which in this case was equation 1, and say, instead of putting that t into equation 2, I can put L plus 2. You write down, substitute 1 into 2. You're telling the person who's reading your work what you are doing. Write down equation 2, L plus T is equal to 16. And then in your next line, you write L plus, now instead of T, you substitute L plus 2. So L plus 2 is 16. Then you solve that equation. I got L is equal to 7. So I know what L is. I need to find out what T is. So I go to equation 1, which is a nice easy one to tell me what T is. I say T is equal to L plus 2. So that means T is equal to, I now substitute 7 for L. 7 plus 2, I get T is equal to 9. You check your answer by substituting in the equation that you didn't use over here. So in this case, it's 2. Equation 2 says L plus T is 16, L is 7, T is 9. If I add 7 and 9, I get 16, and so I know I'm correct. Before we move on to another example, I just want to consider the previous example. We had an equation that said T is equal to L plus 2. This is different to the equations that you've been solving because it has two variables. And when a single equation has two variables, there are infinitely many answers. You could say 5 is equal to 3 plus 2, in which case T would be equal to 5 and L would be equal to 3. Or you could say 11 is equal to 9 plus 2, in which case T would be equal to 11 and L would be equal to 9. The other equation that we had was that L plus T is equal to 16. Once again, we have two variables, and when you have two variables in one equation, there are infinitely many solutions. I could have 0 plus 16 is equal to 16, which means L is equal to 0 and T is equal to 16. I could also have negative 6 plus 22. That's also equal to 16. In this case, L is equal to negative 6 and T is equal to 22. As you can see, I can carry on just doing this forever and never run out of solutions. When I say that these two equations are simultaneous, it means I have to find the answer that makes both of them work. So it's a system of equations. T is equal to L plus 2 and L plus T is equal to 16. When we solve this, we got t is equal to 9 and L is equal to 7. And we saw that it works, that solution works in this equation and in that equation, which is why there's just one answer. There's only one answer to the simultaneous equation. It's the answer that makes both equations work. Here we have a set of simultaneous equations that we need to solve. They are just two abstract equations. You haven't been given a real-world context, but it makes no difference. If I call the top one equation 1 and the one underneath equation 2, and I look at it, I see in the top equation, in equation 1, it says x is equal to y plus 6. So I've just got x by itself on this side and y plus 6 there. That means that what I can do is I can take y plus 6 and write it in this equation in the place of x. I write down, I am going to substitute from equation 1 into equation 2. So what you do is you write down equation 2, x plus 2y is equal to 15, and then in the next step, in the place of the x, you write y plus 6. So it's y plus 6 plus 2y is equal to 15. On the left-hand side, I add my like terms. Y plus 2y is 3y, plus 6 is equal to 15. I want to isolate the y in the end, so I'm going to subtract 6 from both sides. So 3y plus 6 minus 6 gives me 3y is equal to 15 minus 6 is 9. And then I can divide by 3 on both sides to eliminate the 3 times y. 3 divided by 3 is 1y is equal to 9 divided by 3 is 3. Then I am going to substitute for y in equation 1. You repeat the process just with different equations. So I'm going to write down equation 1 this time. So it's x is equal to y plus 6. Here I have y is equal to 3, and there I have y. So I can substitute that 3 in the place of that y. On the left-hand side, it's x is equal to, and instead of y, I'm substituting 3 plus 6. Now I have a solution for x. X is equal to 9. In this system of equations, in the first equation, equation 1, I have y is equal to x plus 3. And in equation 2, x plus 2y is equal to 3. I can see that I can substitute y over here with x plus 3. So I can take that x, the x plus 3, and put it in the place of y. I'm going to do that. I'm going to substitute equation 1 into equation 2. I write down equation 2. X plus 2y is equal to 3. In the next step, I write x plus, now remember I'm substituting for y. So I write 2, and then instead of the y over here, I'm going to write x plus 3. I need to put that in a bracket so that I multiply the whole thing by 2 is equal to 3. In the next step on the left-hand side, I must remove my bracket. I have x plus 2 times x is 2x, and 2 times 3 is 6, is equal to 3. On the left-hand side, I have 3x plus 6 is equal to 3. To isolate my x term, this x term here, I need to subtract 6 from both sides. On the left, I have 3x plus 6x minus 6 will just give me 3x. And 3 minus 6 is negative 3 on the right-hand side. I divide by 3 on both sides. On the left-hand side, 3 divided by 3 is 1x. And on the right-hand side, negative 3 divided by 3 is negative 1. So I've solved for x. Now, if I use this equation 1 and I put a negative 1 in the place of x, I'll be able to solve for y. I must write down what I'm doing. So I'm going to substitute for x in equation 1. I write down equation 1, y is equal to x plus 3. Then I'm going to substitute for x. X is equal to negative 1, so in the place of this x, I'm going to substitute negative 1. Y is equal to negative 1 plus 3. Y is equal to 2. I've solved for x and y, and I'm going to check my answer. Remember that you've got to check your answer. I substituted in 1 here, so I'm going to check my answer in 2. I'm going to substitute for x and y in 2. Write down equation 2. X plus 2y is equal to 3. X is equal to negative 1. So x is equal to negative 1. So in the place of x, I write negative 1 plus 2 multiplied by, and y is equal to 2. So y is equal to 2. And that must equal 3. I've got negative 1 plus 4 is equal to 3. Negative 1 plus 4 is 3. 3 is 3. The two sides are the same, and my answer is correct. Okay, I think you're ready to get on and try some on your own. It's exercise 5 and exercise 5 star in your textbook on page 191.